Okay, I will jump straight to showing you what's happening in part 4. But before I start part 4, I need to orientate you to what we have found in front. So let's say this is your y equation. It's your usual differentiation before I have found the Maclaurin series for y. So for this answer, I have already listed down for you here. This is for the Maclaurin series of y. Now, what will happen after this? Then I jump straight to part 4. They say that can we let the result in part 2 be called hx, which means that they would like to call this as an hx equation. This is my hx. We find the set of values of x for which h will differ from y by less than 0.5. The crucial part I need you to know is this particular statement. What is the meaning of differ from y? When you see differ, when we start the equation, I will write hx difference with y. This is the meaning of differs, but you don't know h is bigger or y is bigger. You just want the positive difference. So when you see the word differs, can we insert a modulus? Okay, so I just note for you here, when you see differs, insert modulus. You want to take the difference, but you mod it first. And that difference must be less than 0.5. This is what they mean. How do we solve for this? Let's replace out the hx. Hx is from the equation that we have found earlier on, so I'm going to replace it. My y equation came from the initial given part, so can I change that into the initial equation? And so this whole thing is lesser than 0.5. How do we solve for something like this? We're going to take this equation from the left. Let's call this a y1 on the graphing calculator. You're going to key as a y1. Okay, don't try to simplify anything. Just key to the GC. This is y1. The one on the right is your y2 equation. So what we are looking for in the graph is when is your y1 graph lower than the y2 graph? Anything that you solve with the graphing calculator, if it's a sketch, you have to provide a sketch such as something like that. When is the graph lower than 0.5? It will be somewhere here. This segment is lower than your 0.5. So we will take the x values from this current range of numbers. So my x will run from minus 0.9 to 0.458. Okay, hence, you state as a set of solutions and your final answer. Okay, use graphing.